Hey guys, welcome back to another edition of Geometry with me, your host, Algebra Anderson. Hey, welcome. Today we're going to talk about section 4.2, angles of triangles. But first you might be wondering, what shirt am I wearing? Look, it's Star Wars. So why? No reason. Just like Star Wars. Okay, so Star Wars is our theme of the day. Today, let's take a look at our objectives first of all. We're going to learn to apply the angle sum theorem, the triangle angle sum theorem, and then the exterior angle theorem as well. Okay, just those two things today. All right, so first of all, what is the triangle angle sum theorem? Well, if you notice here what it says the sum of the measures of the angles of the triangle is 180 degrees. And you may know this before, but basically this just says, hey, if you take these three angles here, angle A, angle B, and angle C, you add them together, you'll equal 180. Okay. You may not have ever thought before, well, why is that? You just hear somebody, they talk about it, hey, it's 180, it's 180. Let me just show you something here. This is pretty cool. Remember what we've been talking about with parallel lines in the last chapter? Remember we talked about certain pairs of angles that are congruent to each other when you get a line that cuts across? Well, here you notice this line and this line are parallel. So you notice we do have a triangle here, and we've made these two lines parallel. Okay, so look at angle 4, 2, and 5. Okay, so basically if we said here, we would say the measure of angle 2, 4, and 5 together would equal 180, right? Because that makes a straight line. That plus that is 180. Okay, because it makes a straight line. Now look what else we know here. Okay, if we have parallel lines, remember, and this is the line that cuts across, so this is one of the lines that cuts across. Look at angle 4 and angle 1. Angle 4 and angle 1 are congruent, right? So angle 1 is congruent to measure of angle 4. So 1 and 4 are congruent because they're alternate interior angles. Remember, they're both inside the two parallel lines on opposite sides of that transversal. All right, what about 5 and 3? If you look at that, here's another line that cuts through those parallel lines. 3 and 5 are also inside, interior, and they're on opposite sides of the transversal. And so we also know that the measure of angle 3 will be congruent to the measure of angle 5. Okay, so now all we'd say is, hey, you know what? If 1 is the same as 4 and 3 is the same as 5, I could just make those substitutions here. Remember what I just wrote up here? So I could say, well, that means that the measure of angle 2 plus, well, 4 is the same as 1, so I could substitute 1. 5 is the same as 3, so I could substitute 3. And we said, well, that has to equal 180. And if you look, what's angle 1, angle 2, and angle 3? 1, 2, 3. Okay, that's why it equals 180 degrees. Pretty cool, right? Okay, let's look at an example here. Here's a diagram, softball team. They've made a drill here, and they throw the ball around in some crazy fashion. But our whole thing is we want to find the measure of each angle here. Okay, so using what we've known, let's try to find out angle 1, angle 2, and angle 3. All right, well, where would you start? Well, I would look at the two triangles, and you say, hey, in this triangle over here, if I have 43 and 74, all I'm missing is one angle, angle 1. Okay, and so what do I know about a triangle? There's supposed to be 180 degrees in that triangle, right? And so if there's 180 degrees in that triangle, and I take away this angle, 43, and then I take away this angle, 74, whatever's left there will be my angle 1. So just 180 minus 43 minus 74. And so that's going to give me 63 there. So that's the measure of angle 1. 63. Okay, well, what can we do next? Now that we know that this is 63, I said, okay, that's 63 degrees. What else? Remember something we learned earlier this year? look, what's angle 1 and angle 2? Together they're vertical angles, right? And we know that vertical angles are congruent, okay? So that means angle 2 has to be 63 degrees as well. So the measure of angle 2 also has to equal 63. Okay, we got one left now. Well, now look at this angle triangle on the right. We know 2 of the 3 angles, and so what can we do here? Same things we did in the first one, 180, but this time we're going to take away 79, and then we're going to take away 63, and then what's left will be angle 3 here, and so that's 180 minus 79 minus 63. And that is 38. And so that's the measure of angle 3. Okay? Feel pretty good with that? Hopefully not too bad. All right, next one. Now we're going to talk about the exterior angle theorem. Okay, so this is something you may not have seen before, but it's kind of along the same lines as what we're dealing with here now. Okay, so first of all, exterior. What does exterior mean? Exterior is outside the triangle, okay? So in this triangle over here, in the middle of this triangle, this is interior, and anything else out around here is exterior, okay? So it talks about this exterior angle. What that means is if you take a triangle and you take one side and you just continue it on out past the edge here, it's going to make an exterior angle, like in this case, angle 1. That is an exterior angle. And so what this theorem says that if that angle is equal to the sum of the measures of the other 2 remote interior angles. Okay, well, what does that mean? I'm going to put some numbers in here. If this is angle 1, the other angle that's next to it is angle, I'm going to call that angle 2. I'm going to call this angle 3. I'm going to call that angle 4. Okay, just so we can more easily tell these, name these angles. All right, angle 1 and angle 2, they're a linear pair. They're right next to each other. They make a straight line. And so they add up to be 180 degrees, right? So the measure, I'm going to do it this way, of angle 1 and the measure of angle 2 equals 180 because they're a linear pair. Well, what else do we know? We also know from what we just learned that 2, 3, and 4 are the measures of an angle of a triangle, so they'll also equal 180, right? So you say the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 have to also equal 180. And so if both of these things together have to equal 180, then you know, hey, if you look what's in common. You got angle 2 here. And so in this case, if you add angle 1 to angle 2 to equal 180, and in this case you add 3 and 4 to angle 2 to equal 180, then angle 3 and angle 4 have to equal angle 1. Okay, that's what this theorem is saying is these other 2 angles over here together will equal 1. So 3 and 4 together will equal 1 because together 1 has to make 180 with 2 and also 3 and 4 has to make 180 with 2. Okay, does that make some sense? And so what sometimes people get confused on here is which ones are the remote interior angles. All that means is wherever your exterior angle is here, in this case 1, it's not the angle that's right next to it. Remote means far away, okay? And so what angles are the farthest away from angle 1? 3 and 4, okay? So that's what we're talking about there when we talk about remote interior angles. Let's look at an example. Okay. All right, in this situation, now it's a little bit more complicated because we're going to do some algebra here too. But here's the exterior angle, the 2x minus 48. Okay, well, what is that equal to? According to what we just said, that is equal to the 2 remote interior angles, which would be x and 32. These are the angles that are the farthest away from that on the inside. Okay, not this one, but these 2. So what do we know? We know that x plus 32 has to equal 2x minus 48. These 2 together have to equal that one. Now I've got an equation, and now I can solve this. So I'm going to go minus x plus 48, and then 2x minus x is just x, and then this will be 80. Now, that's what x is, right? X is 80. We just solved x, but what did they ask us for? They said find the measure of FLW. So we're trying to find the measure of this angle right here, okay? So all we have to do that is plug that back in, so the measure of angle FLW would be what? 2 times 80 minus 48. And so in that case, we just do 2 times 80 minus 48, and it looks like we get 112. Okay? Does it seem okay? Feeling okay with that? Let's take a look at another one. Okay, how about this one? All right, quilt fabric. I guess that's why it's like all, what do you call this here? That pattern, the plaid pattern. Okay, it's in the shape of a right triangle. So we have a right triangle here. Notice this is 90 degrees, this is x. We want to find the measure of ACD. Okay, so here's ACD out here. So again, we're going to think along the same lines as we say, oh, well, this is the exterior angle. Well, x and 90, remember this is 90, those are the remote interior angles. So we would have to say that x plus 90 would have to equal 3x plus 10. That's our equation there, that those two added together have to equal that one. Minus x minus 10. Oh, this is interesting. So 2x equals 80. There's 80 again. Oh, but wait, that's 2x, so divide by 2. And so we got x is 40. All right. Oh, but wait, what were we trying to find again? We were trying to find the measure of ACD, not x. So it's not going to be b there. We have to plug it in over here to this, and so this is going to be 3 times 40 plus 10, which equals 120 plus 10, which is 130. And so it looks like that's going to be letter D there. So magic red bouncing ball, please enter. And there it is, 130. Good. Okay. All right, couple of quick sidelights here. Triangle angle sum corollaries. These are just a couple of things that are based off of what we've just learned that may be helpful to you at some point. This first one here says the acute angles of a right triangle are complementary. So in other words, if these all have to add up to 180 and you know you have a right angle, the other two together have to be 90. Kind of makes sense, right? And then the second one here, it says there can only be one right or obtuse angle in a triangle. So again, if say L is a 90-degree angle, the other two together have to be 90. So they excuse me, they have to be less than 90. They have to be acute. And of course, if L is obtuse, you know, it's even more so there. Okay, so a couple of things there that could help you. It might help you a little bit along the way as you work things out. All right, a couple more examples and we'll be done. All right, find the measure of each numbered angle. Whoa, okay, this looks a lot more complicated here. Now, doesn't it? Look at all these angles, look at everything. All right, well, let's just go through one by one and figure out each angle, okay? All right, well, where could we start with? Well, why don't we start with angle 1 right here, okay? Let's start with angle 1. And so if you look at it, look at this triangle right here. And then from that one side, it comes off here. So angle 1 is exterior, okay? So angle 1 is exterior. Well, remember, the exterior angle will equal the two remote interior angles. Okay, so that would be 48 and 56. So that means that if we do 48 plus 56, that will give me the measure of angle 1, which is 104. So 104 is the measure of angle 1. Okay, because it was these two added together. So I'm going to write it here in red. So this is 104 degrees there. Angle 1's 104. Okay. Once we find out an angle, we can always use that to find other angles as well. And so in this case, look at angle 1 and angle 2. Together, they make a straight line. Well, that's a linear pair. Remember, a linear pair has to add up to be 180. So to find angle 2, all I have to do is take 180 minus 104. Just subtract that one out. What's left? 76. So the measure of angle 2 is 76. All right, I'm going to write that one in there. So we have that one to refer to, 76 degrees. So far okay? Getting this? Okay. Okay, let's move on. Let's look at 3 next. Okay, a little bit more going on here, but if you look, there's a right angle symbol right here. And of course, this is a straight line. So what do we know? We know if that's a right angle, that this here also has to be a right angle. Those two together have to also be a right angle, right? So in this case, to find the measure of angle 3, we know that those have to add up to be 90. So if I take 90 and I subtract out 48, then I will get the measure of angle 3 in that case. And so in that case, that's what, 42 is the measure of angle 3. Okay, so 42 degrees here. Okay, now what can we do here? Now, what about angle 4? There may be a couple different things that you could do here that you could try to do. You could look at this little triangle right here, and since this is 90, you could find out what this angle is in here, and then take 180 minus 76 and minus this one. Or I'm going to show you something else. Might blow your mind. Okay, watch this. Instead of looking at that small triangle, look at this big triangle right here. See the one that I'm outlining there? You got 42 degrees up here. Down here, the whole thing is 90, and then there's 4. So instead of looking at that small triangle, look at the big triangle, and you say, oh, well, think about this. Remember one of the corollaries that we just looked at was if you have a right angle in the triangle, the right triangle, the other two have to add up to be 90, right? So you say, hey, here's a right triangle, 90 degrees. That means 3 and 4 together are supposed to be 90. So in other words, I can do 90 minus 42. And what do I get? 48. Oh. So that might be a little bit, so sometimes you can use that. That might be make that a little bit easier when you're trying to figure these things out. You know, instead of doing like 90 minus 34 to get this, and then doing that plus 76, you know, and then subtract that from 180. So sometimes you can make it a little easier on yourself. And then lastly, again, if you look at this, we've got angle 5 over here. Here's a right triangle again. So angle 5 and 41 degrees together should make up 90. So in other words, if I take 90 and I subtract out 41, I should get angle 5. And in that case, that's what, 49 degrees, which is the measure of angle 5. Okay? And so 49 degrees up here. And as you figure these things out, how you can kind of check yourself is add up in each little triangle, you can add those 3 up. Is 49 plus 41 plus 90, does that equal 180? Remember, you know, you've got, like here, angle 1 was 104, which means vertical angle. This is also 104. So is 142 and 34 and 104, does that all equal 180? And it should, 76 and 104. Yes, so you can kind of double check yourself to make sure all those things work, okay? All right, last one and we're done. Find the measure of angle 3. So just kind of like what we've been doing, we're going to piece some things together. So where I'm going to start here is I'm going to go, hey, here's 2 angles. I can find angle 1. I'm going to start out with that, right? Because if I just do 180, I subtract 45, and then I subtract 85, I will have what's left over there. So 180 minus 45 minus 85 is 50. So the angle 1 here is 50 degrees. Well, what do we know? Angle 1 and angle 2 are vertical, so this is also 50 degrees in here. So piece that together. On this side over here, we notice, hey, 135 and this angle right here are a linear pair, so they will add together to be 180. So all I would have to do there is go 180 minus 135. And that would be 45. And so if this is 45, and now that I've found those two, now to find angle 3, all I would have to do is what? 180 minus 50 minus 45, and that should equal 85. Okay, you see that? And so, magical bouncing ball, 85. All right, we got it. Good. So there's a little bit about the triangle angle sum theorem and the exterior angles. Some things that you can do as you're figuring out the relationships there with just the different triangles and the angles and things like that. So anyway, appreciate you being here. Hope you learned something, and we'll see you next time. This is Mr. Anderson saying so long. Bye.